Look around you right now. You are holding a device made of metal, glass, and plastic. You can feel its weight in your hand, hear the soft hum of the room around you, and see the light reflecting off the screen. But more than that, you are aware that you are doing these things. You are not simply a biological machine reacting to input and output. There is an internal experience happening inside your mind. There is a felt quality to being you. You experience the vivid redness of an apple, the sharp sting of cold air on a winter morning, and the heavy, aching weight of nostalgia. This internal subjective experience is what we call consciousness. It is the most immediate, intimate reality of our lives. Everything you have ever known, loved, hated, or imagined has passed through the lens of your conscious mind. Without it, the universe would exist, but there would be no one to notice. It would be a sprawling, magnificent performance occurring in an empty theater. Yet, when we turn our most powerful tools of science toward the physical world, we encounter a profound and deeply unsettling mystery. According to the laws of physics and chemistry, the universe is made of fundamental particles, quarks, electrons, and photons, governed by predictable forces like gravity, electromagnetism, and the nuclear interactions. Over billions of years, these particles drifted through the cosmos, pulled together by gravity to form stars, planets, and eventually, on a quiet blue rock floating in the dark, complex biological organisms. If you look at the human brain through a microscope, you do not see thoughts, feelings, or colors. You see roughly 86 billion neurons. These neurons are cellular engines, firing microscopic electrical signals and swapping chemical signals across trillions of connections called synapses. They operate through chemistry and physics, following the exact same laws that govern a falling rock, a burning candle, or a crashing wave. And here is the mystery that keeps physicists, neuroscientists, and philosophers awake at night. Why should any of that physical processing feel like anything at all? Why doesn't the brain just process information in the dark? A modern computer can perform billions of complex calculations every second. It can beat grandmasters at chess, generate human-like sentences, and navigate self-driving cars through busy city streets. Yet, as far as we can tell, there is no light on inside the computer. There is no inner world. The machine does not feel the satisfaction of winning a game or the anxiety of a close call. It processes data without any subjective experience whatsoever. So why aren't we like that? Why aren't we biological automatons, complex organic machines that walk, talk, eat, and reproduce, but with zero inner life? Why did the universe, governed by cold, unfeeling laws of physics, give rise to a subjective world of pain, joy, wonder, and self-awareness? Why does consciousness exist? To understand how profound this question really is, we have to travel back to the origins of modern science. In the 17th century, thinkers like René Descartes and Galileo Galilei made a quiet pact that would shape the next 400 years of human inquiry. They decided that to truly understand the physical world, science needed to measure things objectively. Science would focus on properties that could be weighed, measured, and calculated, things like length, mass, velocity, and electric charge. Subjective qualities, the sweetness of honey, the warmth of sunshine, the feeling of love, were set aside. They were considered secondary, personal experiences that existed only in the mind of the observer. By removing the subjective observer from the equation, science made extraordinary leaps forward. We unlocked the laws of motion, uncovered the structure of the atom, mapped the genome, and decoded the light from distant galaxies. But this grand strategy left behind a massive, hidden debt. By defining physical science as the study of the objective, external world, we excluded the subjective observer from our basic description of reality. Now, centuries later, when we try to use that same physical science to explain the observer itself, we find ourselves staring into a massive conceptual chasm. Philosopher David Chalmers famously gave this puzzle a name that has become legendary in modern science: the hard problem of consciousness. Chalmers pointed out that there are easy problems in neuroscience, though easy is a relative term. The easy problems involve mapping the functional mechanics of the brain. How does the brain process visual information from the retina? How does it store memories? How does it control our muscles or regulate our heartbeats? These are immensely difficult engineering challenges, but scientists agree on how to solve them. With enough time, better brain scanners, and advanced computational models, we will eventually map out the neural circuitry for every action, reaction, and cognitive function. The hard problem, however, is fundamentally different. Even if we mapped every single neuron, tracked every electrical impulse, and charted every chemical reaction in a living human brain down to the atomic scale, a fundamental question would remain completely unanswered. How does all that physical activity produce a subjective feeling? How does an electrical impulse moving through a wet mass of tissue become the vivid, personal sensation of seeing the color blue? Why should a chemical interaction at a synapse feel like grief or joy? There is no obvious bridge connecting physical matter in motion to subjective experience. You can describe the physical properties of light waves hitting an eye, and you can map the nerve signals traveling down the optic nerve to the visual cortex, but nowhere in that physical chain of cause and effect do you find the experience of red. This realization leads to a breathtaking conclusion. Consciousness might not be an accidental side effect of biology, but one of the deepest unresolved paradoxes in all of physics. To appreciate the gravity of this puzzle, let us look at how mainstream biology and evolutionary theory attempt to explain it. From a purely Darwinian perspective, every biological trait that survives and thrives over millions of years must offer an evolutionary advantage. Traits that help an organism survive, find food, avoid predators, and pass on its genes are selected for. Traits that carry an immense energy cost without offering a survival benefit are usually discarded. The human brain is an energy-devouring monster. It accounts for only about 2% of your body weight, but it consumes over 20% of your body's total energy budget. Maintaining 86 billion active neurons is metabolically expensive. If consciousness is a product of this massive biological computation, it must serve a vital purpose. It must help us survive. At first glance, the survival value of consciousness seems obvious. If you touch a hot stove, you feel sharp pain. That pain teaches you never to touch the stove again. If you feel hunger, it drives you to hunt or forage for food. If you feel affection, it encourages you to protect your children and cooperate with your tribe. But if you look closer, the mystery deepens. Why did those survival behaviors need to be accompanied by subjective feelings? Why couldn't our bodies process environmental dangers, store memory patterns, and alter our behavior purely through unconscious biological feedback loops? Why did nature go through the immense trouble of creating an inner world of real, felt suffering and genuine pleasure, when cold, unconscious data processing could have achieved the exact same physical outcome? Some scientists and philosophers argue that consciousness is simply what complex information processing feels like from the inside. They suggest that once a system reaches a certain threshold of structural complexity and feedback loops, subjective awareness automatically ignites like a spark catching fire in a dry forest. This idea forms the basis of integrated information theory, developed by neuroscientist Giulio Tononi. This theory attempts to measure consciousness mathematically. It proposes that consciousness is not unique to brains, but is an intrinsic property of any system that processes integrated information. The more interconnected a system's parts are, where the whole system contains significantly more information than the sum of its individual components, the higher its level of consciousness. According to integrated information theory, a simple light switch has a tiny, almost infinitesimal amount of consciousness because it integrates a binary state. A smartphone has more. A biological brain, with its trillions of hyperdense interconnected synapses, possesses an extraordinarily high degree of integrated information, resulting in the rich, continuous stream of subjective experience we call human consciousness. If integrated information theory is correct, it leads to a staggering conclusion. Consciousness might not be limited to living organisms. It might be woven into the structural fabric of information processing itself. It implies that as our artificial intelligence models become more complex and their internal networks more deeply integrated, a point will come where the lights suddenly turn on inside the machine. Not because we programmed a soul into the code, but because subjective experience is the natural mathematical consequence of highly integrated information. Yet this theory faces fierce opposition. Critics argue that calculating information processing does not explain the transformation from math to feeling. A supercomputer running a weather simulation can calculate every air molecule, temperature gradient, and pressure drop of a massive hurricane. The simulation can be extraordinarily complex and integrated, but the computer does not get wet. The simulation is not an actual storm, it is a mathematical description of a storm. Why then should a complex simulation of information inside a brain produce actual, felt experience rather than just a mathematical description of experience? This brings us to a radical, mind-bending perspective that has gained traction among some modern physicists and philosophers: panpsychism. Panpsychism is one of the oldest ideas in human history, but it is experiencing a major scientific renaissance today. To understand why serious scientists are reconsidering this ancient concept, we have to look closely at what modern physics actually tells us about matter. Physics is exceptionally good at describing what matter does, but surprisingly silent on what matter is. Consider an electron. Physics can tell you the mass of an electron with extreme precision. It can tell you its electric charge, its spin, and how it interacts with magnetic fields. It can give you complex wave equations that predict where the electron is likely to be found. But all of these measurements describe the electron's interactions and relationships: how it moves, how it attracts or repels other particles, and how it responds to forces. Physics describes the external behavior of matter, but it tells us almost nothing about the intrinsic nature of matter itself. It describes the rules of the stage and the movements of the actors, but it does not tell us what the actors are made of when they are not acting. Panpsychism offers a daring proposal to solve this blank spot in physics. It suggests that physical science has been describing only the outer shell of reality. The intrinsic, internal nature of matter, the fundamental stuff that carries charge, mass, and spin, might be a primitive form of experience itself. According to panpsychism, consciousness is not a bizarre, magical phenomenon that somehow emerges out of non-conscious matter when you stack enough dead atoms together in a brain. Instead, consciousness is a fundamental building block of the universe, just like mass, electric charge, or space-time. In this view, fundamental particles like electrons and quarks do not possess human thoughts, hopes, or memories. They don't have brains or complex minds, but they do possess an unimaginably simple, rudimentary form of subjective presence, a tiny spark of raw experience. When those fundamental particles are forged into stars, planets, and eventually organized into the hypercomplex, interconnected architecture of a living brain, those billions of microscopic sparks of experience combine to form the roaring, unified river of consciousness that you are experiencing right now. If panpsychism sounds absurd at first, consider the alternative that mainstream science currently assumes: materialism. Materialism states that the universe began with absolutely zero consciousness. For billions of years, there were only dead, unfeeling, unconscious particles bumping into each other in the void according to physical laws. Then, through purely physical combinations, suddenly, out of nowhere, dead matter miraculously transformed into subjective experience. Unfeeling light waves hitting unfeeling flesh somehow birth a felt experience of bright colors. Dead atoms organized into a specific sequence suddenly woke up and began to experience pain, love, and awe. To many thinkers, this sudden jump from completely non-conscious matter to subjective awareness is just as strange and unexplained as magic. It is the scientific equivalent of pulling a living rabbit out of a hat that never contained a rabbit in the first place. Panpsychism avoids this miracle by suggesting that the rabbit was always there. Consciousness didn't suddenly appear out of nothing. It was built into the raw material of the universe from the very beginning. But panpsychism faces its own brutal paradox, known as the combination problem. If an electron has a microspark of experience, and a proton has another microspark of experience, how do billions of these independent, microscopic bits of awareness bind together to form a single, unified, continuous human mind? When you look at a painting, you don't experience a billion separate, pixel-sized thoughts. You experience one unified visual scene. You hear music, feel your breathing, and think about tomorrow all at the exact same time, blended into a single point of view. How do microscopic, isolated consciousness units join together to form one big you? Science currently has no answer. As we push deeper into this mystery, the boundary between the observer and the observed begins to dissolve entirely, leading us directly into the weirdest realm of modern science: quantum mechanics. For nearly a century, quantum physics has forced scientists to confront an unsettling truth about reality at the smallest scales. At the subatomic level, particles like electrons do not behave like tiny billiard balls sitting in fixed locations. Instead, they exist in what physicists call a superposition, a cloud of mathematical probabilities where a particle can effectively be in multiple places or states at once. The quantum world remains a hazy realm of possibilities until a measurement or observation occurs. The moment a measurement is made, the spread-out wave of probabilities instantly collapses into a single, definite reality. The particle chooses a specific location and the blurry quantum haze solidifies into a hard, physical fact. This phenomenon is known as the wave function collapse, and it lies at the very heart of physics. But it raises a deeply uncomfortable question that has sparked intense debate since the 1920s. What actually counts as a measurement? What collapses the wave function? Some of the founding fathers of quantum mechanics, including legendary physicists like John von Neumann and Nobel laureate Eugene Wigner, proposed a radical answer. They suggested that physical systems alone, detectors, mirrors, and laboratory equipment, are ultimately made of quantum particles themselves. Therefore, a physical detector cannot collapse a wave function. It simply becomes entangled with a particle, joining the blurry state of superposition. The only thing in the universe that is fundamentally distinct from physical matter, they argued, is conscious awareness. According to this controversial interpretation, the wave function collapses only when the outcome of an event is observed by a conscious mind. In this view, consciousness is not a passive spectator sitting safely in the audience watching the universe go by. Consciousness is an active participant in reality, pulling the physical universe out of a fog of quantum probabilities into a concrete, actualized existence. Physicist John Archibald Wheeler captured this idea in his famous concept of the participatory universe. Wheeler suggested that the cosmos is not a finished product sitting outside of us. It is an interactive system that requires conscious observers to bring it into definite reality. Imagine a universe without a single conscious eye to look at it, without a single mind to measure it. In Wheeler's view, such a universe would remain forever suspended in an uncollapsed state of pure probability, a ghost cosmos of endless potential, but no actualized reality. Wheeler used a simple, striking image to explain this: the universe as a self-observing loop. Picture the cosmic history of the universe as a giant letter U. On one side of the U, billions of years ago, the Big Bang explodes, creating space, time, matter, and energy. For eons, stars condense, galaxies form, and heavy elements are forged in cosmic furnaces. Then, on the other side of the U, on a tiny rocky planet orbiting an ordinary star, matter organizes itself into life. Life evolves, grows complex, and develops conscious minds. Those conscious minds turn around and look back across the vast expanse of space and time, observing the very Big Bang that created them. Through conscious minds, the universe looks back at itself. The loop is closed. The cosmic observer actualizes the cosmos that created it. If this idea is correct, it completely flips our traditional view of reality upside down. We are used to thinking that matter is primary and that consciousness is a late accidental arrival, a thin layer of green moss growing on a cold, ancient rock. But quantum physics and cosmology leave room for a far more breathtaking possibility. Consciousness might be primary. Matter and energy might be the secondary manifestations of underlying conscious reality. This leads us to one of the most profound theoretical physics models of modern times, developed by Nobel laureate Sir Roger Penrose and neuroscientist Stuart Hameroff. Their theory, known as orchestrated objective reduction, attempts to bridge the gap between quantum physics and human biology. Penrose argued that standard computation, the kind of step-by-step math that computers and traditional brain models use, can never fully explain human consciousness. He pointed out that human mathematicians can grasp truths about numbers that cannot be proven by step-by-step algorithms, suggesting that our minds do something fundamentally non-computational. Where could this non-computational process happen inside the wet, warm environment of the human brain? Hameroff suggested looking inside the neurons at tiny structural scaffolding components called microtubules. Microtubules are hollow, cylindrical structures that support the shape of cells and transport materials inside them. Because of their symmetry and tiny scale, Penrose and Hameroff proposed that microtubules might be capable of maintaining quantum states without collapsing immediately. They suggested that quantum processes inside these tiny tubes become entangled across vast networks of neurons. When these quantum states reach a specific threshold defined by quantum gravity, they collapse naturally, an event Penrose calls objective reduction. According to this theory, each objective reduction event is a micro-moment of conscious awareness. When billions of these micro-events are organized or orchestrated, by the structural architecture of the brain, they produce the seamless, continuous flow of human thought and feeling. If Penrose and Hameroff are right, your mind is not a digital computer running biological software. Your brain is a quantum instrument directly plugged into the fundamental structure of spacetime at the smallest possible scale. Consciousness is not produced by the brain. The brain is an antenna tuned to catch and organize a fundamental property of the cosmos. Whether we look through the lens of neuroscience, information theory, quantum mechanics, or philosophy, we keep bumping into the same astounding realization. Consciousness refuses to fit neatly into our standard picture of a dead, mechanical universe. And so we return to our original, simple question: why does consciousness exist? Perhaps the answer lies in the true nature of existence itself. Think about what it means for something to exist. If a universe existed with stars, black holes, supernovas, and galaxies, but had no conscious entity to observe it, feel it, or contemplate it, does that universe truly exist in any meaningful sense? Without experience, concepts like beauty, time, distance, and meaning simply vanish. Without consciousness, a sunset is not beautiful. It is merely electromagnetic radiation of wavelengths between 400 and 700 nanometers striking an unfeeling surface. Without consciousness, a supernova is not a magnificent cosmic catastrophe. It is merely a rapid thermal expansion of matter following differential equations. Consciousness is the mirror in which the universe discovers its own existence. It is the magic lens that translates raw mathematical physics into meaning, value, and feeling. But the science of consciousness offers a radically different perspective. You are not just a passive spectator sitting on a tiny rock looking out at a vast universe. You are the universe looking back at itself. The atoms that make up your brain, the iron in your blood, the calcium in your bones, the carbon in your DNA were forged inside the burning hearts of giant stars billions of years ago. Those stars exploded, scattering their ashes across the dark void. Over billions of years, those ashes gathered into planets, crept out of ancient oceans, grew complex, developed nervous systems, and eventually woke up. Perhaps consciousness exists because a universe without awareness is incomplete. Perhaps the cosmic story required an audience, and so the universe spent 13.8 billion years building an observer from its own dust. You are not separate from the cosmos trying to understand it. You are the cosmos coming to know itself.